Arithmetic progressions. You can see a part of an auditorium. The first row has 25 seats. The second row has 7 more seats than the first row. The number of seats in each succeeding row increases by a fixed number 7. How many seats will be there in the 10th row? How many rows will the auditorium need so that the capacity is 1,110 people? This is an example of arithmetic progression. You will be able to solve this problem at the end of this module. Derivation of the nth term. Derivation of sum of first n terms. Let T1, T2, T3, and so on up to Tn be the terms of an arithmetic progression. Let D be the common difference between the successive terms. T2 minus T1 is equal to T3 minus T2 is equal to T4 minus T3, and so on. That is equal to Tn minus Tn minus 1, that is equal to D. The first term T1 is A, and it can be written as A plus 1 minus 1 into D. Following the same pattern, we can write the second term T2 as A plus 2 minus 1 into D. Now write T3 and T4 using the same pattern. Key in the answers. Following the same pattern, we get the nth term Tn is equal to the n minus 1th term, that is Tn minus 1 plus D, that is equal to A plus n minus 1 into D. The general form for the nth term of an arithmetic progression is Tn is equal to A plus n minus 1 into D. In the example of the auditorium, the number of seats in the first row, that is A is equal to 25. The common difference D is equal to 7. Find the number of seats in the 10th row. We use the formula for the nth term and substitute the known values. Key in the values. Key in the answer. We find that there are 88 seats in the 10th row. Let A be the first term of an arithmetic progression of n terms, and let the common difference between successive terms be D. Write the terms of the arithmetic progression. Key in the values. Let us denote the sum of the first n terms of an arithmetic progression by Sn. We get Sn is equal to A plus D plus A plus 2D plus A plus 3D and so on till A plus n minus 1 times D. That equals n times A. Plus D plus 2D plus 3D and so on till n minus 1 times D. That is n times A plus sigma n minus 1 times D. We know that sigma n, that is the sum of the first n natural numbers, is equal to n into n plus 1 by 2. In the same way, sigma n minus 1, that is the sum of the first n minus 1 natural numbers, is equal to n minus 1 into n minus 1 plus 1 by 2. We substitute this value of sigma n minus 1 in the right-hand side of the equation. We simplify the terms. We get the formula Sn is equal to n by 2 times 2a plus n minus 1 into d. We use this formula when we know the values of a, n and d. We can rearrange the terms. We get the formula Sn is equal to n by 2 times a plus l, where l is the last term of the arithmetic progression. We use this formula when we know the values of a, n and l. In the example of the auditorium, the number of seats in the first row, that is a is equal to 25, the common difference d is equal to 7. How many rows will the auditorium need so that the capacity is 1,110 people? We use the formula for the sum of n terms and substitute the known values. Key in the values. We reject the negative value. We find that 15 rows are needed to seat 1,110 people in the auditorium.